All right. On this video, we're going to deal with a scenario whereby we're not provided with a diagram. It's just a question whereby coordinates are provided. What does the question say? It says show that DEFG is formed by the points. We're provided coordinates for point D, E, F, and G. And then the question says show that DEFG is a parallelogram. Now, this is intimidating, right? But what did I do? I went ahead and I drew a parallelogram for you so that you may know, okay, this is how we draw a parallelogram. Now, what do? I come to the coordinates. I have got -5, and here I drew a Cartesian plane. So if I've got -5, probably I'm somewhere here. And then I'm told that the y value is +3. So maybe I'm somewhere here. Then I name it point D here, right? And then from there, I've got point E, whereby I've been told that the x is +3 and the y is +5, right? Okay. So maybe I will say that the x is somewhere here. This is where +3 is found. And then I've got 5. So remember here I said it's 3 because D was -5 and +3, which means 5 is a little bit higher. There we go. Then we've got point F, whereby our x coordinate is 2 and the y coordinate is 1. So it's a little bit back. 2 and 1. There we go. Then last but not least, we've got -6 and -1. Now, remember -6 is smaller than -5. So we're saying that we're somewhere here. And we're told that the y value is -1. So if this is 6, then the -1 is somewhere here. Now, do you observe that if I join these dots, even though I didn't draw my diagram according to scale, you can see the parallelogram. Now I go and I label that this is E, this is F, and this is G, right? So this is point D, E, F, G. Now I'm working with the diagram that I can see. Let's come back again. They've said show that DEFG is a parallelogram. And when I want to show that it's a parallelogram, you are now going to use your information from Euclidean geometry about the properties of a what? Parallelogram. So to prove that, now I know that I've got diagonal GE and I've got diagonal what? DF here, right? And where they meet here, this is what we call the midpoint here. Midpoint. So when we calculate for the midpoint of line DF and the line GE, they've got a common midpoint. We must get the same coordinates. If we get the same coordinates, then we know that it's a parallelogram. So what are we going to do? DF. So I come here and I say midpoint DF is equal to, remember, what does the midpoint say? It now says that XD plus XF divided by 2, and then YD plus YF divided by 2. So I write again midpoint DF. Now this time around I'm going to put the coordinates. What is my exit point? It's -5. So we say -5 plus my exit point F 2 plus 2 divided by 2. Then now I must go for the y-coordinate of point D. The y-coordinate for point D is 3. So I say 3 plus the y-coordinate for point F, it is 1 plus 1 all over 2, like that. Now on this stage, now I say negative 5 plus 2. What do I get? I get negative 3. So I've got a negative 3 over 2. And here 3 plus 1 is equals to 4. 4 divided by 2, it gives me 2. So I got negative 3 over 2 as the x-coordinate and 2 as the y-coordinate. So I conclude that therefore midpoint DF is equals to these coordinates. Now I must find, so I'm done with the first line. I must diagonal line. I must now find the coordinates of GE. So I say midpoint GE is equal to, the x-coordinate at point G is negative 6, so I've got negative 6, plus the x-coordinate at point E is 3. We have 3 all over 2. Then the y-coordinate at point G, is negative 1, plus the y-coordinate at point E, it is 5, plus 5 over 2, like that. We say is equal to, now when I say negative 6 plus 3, I get a negative 3. So I've got a negative 3 over 2 as 2. Negative 1 plus 5, when you punch your calculator, is the same as saying 5 minus 1, which is 4. So we've got 4 over 2 there, which is now equal to, because this one is divisible, negative 3 over 2, like this. Then check. Here we got negative 3 as our x-coordinate. There we got negative 3 over 2 as our x-coordinate. They are identical. Y is equals to 2. Y is equals to 2. So therefore, we say our midpoint for line GE is equal to these coordinates. And since these coordinates are identical, I can then conclude that therefore DEFG is a parallelogram. And just like that, I have proven. Thank you. Now, I want you, if this video was helpful to you, please do join me on the next video, because I will be dealing with proving whether a particular shape that is given is a rhombus or not. If you found this video valuable to you, please do share, comment, like, and subscribe. Thank you.